We interact with technology every day that feels intelligent. A modern microwave heats a meal perfectly to the second, and a network of traffic lights synchronizes the flow of thousands of cars through an intersection. We often call these devices smart, but they are actually examples of automation. They operate on strict, fixed instructions programmed by humans, producing the exact same output every single time without thinking or adapting. True machine intelligence is a completely different process. Instead of blindly following preset rules, an artificial intelligence system builds its own logic by analyzing information and learning patterns from data. The problem is that data in the real world does not arrive in one neat package. It can be incredibly messy, completely unorganized, or in some cases, it might not even exist yet. Because the information they rely on varies so wildly, machines have to use distinct mathematical strategies to teach themselves. This sets up the three primary methods of machine learning. We start with the easiest scenario, learning from clean, highly organized data, where every piece of information comes with a clear, correct answer attached. Think of an image file tagged by a human with the word cat or dog. When a machine uses this kind of tagged information, it is executing supervised learning. This diagram illustrates how the method works. On the left, we feed the system labeled training data, specific shapes that already have the correct name tags attached. The algorithm analyzes this data, finding the relationship between the visual shape and its given label. During testing, we give the model fresh, unlabeled data. It uses the learned patterns to accurately predict the correct labels. This specific mechanism powers the spam filter in your email inbox, identifying junk messages based on millions of previously tagged emails. It is also the exact process medical software uses to predict diseases from vast databases of labeled patient symptoms. We encounter a different challenge when we have millions of data points, but absolutely zero human-provided labels or cheat sheets to guide the machine. To solve this, the system uses unsupervised learning. Without any human answers, the machine explores the raw, chaotic data completely independent of outside guidance. Look at the input phase of this flowchart. Unlabeled data, a random assortment of mixed shapes and colors, is fed directly into the model's analysis center. The algorithm searches through this raw information to discover hidden similarities. It automatically sorts these unknown similarities into distinct groupings. The system doesn't know what a triangle is called, but recognizes they share a mathematical trait and clusters them. This autonomous clustering allows companies to perform massive customer segmentation, grouping millions of buyers with similar habits. It also allows banks to detect bizarre anomalies in transaction data to instantly stop credit card fraud. The final scenario tackles problems where we have absolutely no historical data to feed the machine. We only have an interactive environment and a desired goal. Here, we rely on reinforcement learning. This is a solution that builds intelligence from scratch through rapid, continuous trial and error. This schematic lays out the learning cycle. We see a continuous loop between an agent, our AI, and the environment it operates within. The agent observes its world and takes a specific action. The environment provides a feedback loop. The agent receives a reward for a good move and a penalty for a bad one, maximizing rewards over millions of cycles. This aggressive penalty and reward cycle allows an AI to dominate complex video games, master the rules of chess, and safely navigate a self-driving car through unpredictable real-world traffic. This graphic summarizes the entire modern machine learning toolkit side by side: supervised learning, unsupervised learning, and reinforcement learning. Each targets a distinct state of data. Supervised relies on human answers, unsupervised finds structure in the unknown, and reinforcement learns through interactive action. We routinely project magic onto these systems, assuming they possess human-like consciousness or organic thought. They do not. Artificial intelligence is simply a highly specialized mathematical engine designed exclusively to extract recognizable patterns. The true power and the absolute limitation of any AI system depends entirely on the state, the quality, and the structure of the data we choose to feed it.